In this section here, I don't know, it's called equations of lines, but it's pretty much things that we've talked about in the past, except this time we're going to graph these things. And of course I know we did some graphing earlier, but we want to actually break it down. So we're going to break it down. Let's start with, we're going to start with 2x minus y is equal to 5. So we're given this linear equation and we want to graph it. Now there's 2 points, that's if we can find them, that we want to find on this graph, and then we can connect the 2 points. The first point is we're going to do, let's say we're going to find the Y-intercept point. And then the second point is going to be the X-intercept point. And once we find both the Y-intercept point and the X-intercept point, then we could just connect the dots and draw a line right through it. Okay, so that's really the fastest way to do this. Now the Y-intercept point is where the graph crosses the y-axis, and that's when x is 0. And then we want to figure out, well, what is y going to be? Well, that's easy to do, because what we're going to do is take 0, plug it into our equation. So we're going to have 2 times 0 minus y is equal to 5. And then all we need to do here is solve for y in this problem. So, well, 2 times 0 is 0, and 0 minus y is negative y is equal to 5. We have negative y is equal to 5. We just multiplied negative 1 to both sides. And negative 1 times negative is positive, so y is equal to negative 5. So we know that our y-intercept point is going to be x was 0 and y is negative 5. Now we want to find the x-intercept point. So in order to do that, we know, actually let's go ahead and find this point right here. 0, negative 5. So 0, negative 5. We need to extend, let's extend the x-axis, or the y-axis I mean. So we'll just say it's right here. Okay, so this is the point 0, negative 5. Okay, now we want to find where does it cross the x-axis. Where does this line cross the x-axis? Well, what we're going to do then is we're going to plug 0 in for y, because every point on the x-axis, pick a point, that's where y is 0. Alright, so plug 0 in for y, and we solve for x in this problem. So it turns out that x is 5 halves. So that's going to go 2 somewhere, you know, we're just going to pick somewhere about right here. This may not be to scale, but at least you get the idea. So 5 halves, we're going to say 5 halves is right here on the x-axis. So this point right here, okay, this ordered pair, I guess we should write it up here, is going to be 5 halves, 0. So that's all you need to do. And then what we're going to do is I'm going to attempt to draw a straight line that passes through here and goes up in that direction there. Okay, so this is the graph, alright, that corresponds with this equation right here. If we had to graph this equation, this is what we would get right here. Alright, so we found the y-intercept, the x-intercept, right? Look, and we consider those to be points right here. And then we just drew a line right through them. So that's how you would graph that equation. It's that simple. Find the x-intercept, find the y-intercept, connect, draw a line that passes through both of these points right here. All right, so we're going to be doing a couple more of those, a few more. Alright, so let's graph another one of these. What if we had, let's say we had 4x plus 3x is equal to negative 12. So we want to graph this. First thing we want to find is the y-intercept point. Right, that's that ordered pair. And then we want to find the x-intercept point. And once we have that, then we just connect the dots and be done with it. Okay, so I'm not going to actually draw a graph here. Okay, let's not do a picture this time. The y-intercept point. So remember, the y-intercept point, that is where x is 0. Okay, and we want to figure out what is y. So we plug 0 in for x. Whoa, I got two x's here. One of these needs to be a y. Let's make that a y. How's that? So we plug 0 in for x, and we want to figure out what is y. Well, 4 times 0 is 0, so we end up with 3y is equal to negative 12. And so what we're going to do now is multiply both sides by 1/3. And so y is going to be equal to negative 4, right? 3 times negative 4 is negative 12. And so it looks like our y-intercept point is 0, negative 4. And then let's find the x-intercept. So that's when y is 0 this time. So we're going to come up here, plug 0 in for y. So we have 4x plus 3 times 0 is equal to negative 12. So we end up with 4x is equal to negative 12. So I think if we plugged in negative 3 here, right, negative 3, so x is equal to negative 3. Because negative 3 times, where are we at? Negative 3 times 4 is negative 12, right? Okay, so our x-intercept point is at negative 3, 0. I guess at this point, you know, the whole idea is we was actually trying to sketch the graph of this thing. So once we get those 2 points, 0, negative 4, we'll say that this is, we'll say that, we'll say, we're going to say something eventually. Negative 4 is down here. Okay, this is 0, negative 4, and then negative 3, 0. So x is negative 3. We'll say this is negative 3, 0 right here. And so we would just connect the dots, and we just graphed. We just drew the graph that corresponds with this equation right here. Okay. So remember, find the y-intercept point, the x-intercept point, or whichever one you want to find first, and plot your points on the graph and connect the dots. Alright, so let's look at another one here. What if we had this? Y is equal to 2x, and we wanted to find, so we want to find the y-intercept. I'm not spelling intercept all the way out. I want to find the y-intercept point, and then the x-intercept point. Okay, so we plugged, remember, 0 in for x, and so in this particular case, plug 0 in and y is 0. But what about the x-intercept? Remember, this is when you plug in y is 0. So y is 0. Well, the only thing that you could plug in for x here would be 0 also. So it looks like that the origin, wait a minute, our y-intercept and our x-intercept are both the same point. How in the world are we going to graph this one? We know it passes through the origin. So we've got a point at the origin, but what else do we do? I mean, I need another point so I can draw a line through both my points. Well, it's not going to work this time. But what I could do is I could just plug a number in, right? For x, we could say, well, let's just let x equal 1, and therefore y is going to be equal to 2 times 1, and so y is equal to 2. So now we have another point, 1, 2. Right? So we'll say this is 1, 2 right here. And now we've got 2 points, and we can connect the dots to draw this graph that goes with this equation. All right. Okay. And of course, that's got to happen at least once. What if I wanted to graph x is equal to 5? What in the world do we do now? Well, I guess we better draw an xy axis. Let's use a different color. How about we use purple or something? I'm going to locate 5 right here on the x-axis. If we were to graph this, this is nothing more than just a vertical line. And trying to draw a vertical line. Okay, so this is just a vertical line that passes through 5 on the x-axis. So for example, x is equal to -1, we'd get a vertical line that passes through -1. Alright, what if x is equal to 0? Well, that turns out just to be, let's say, the y-axis. Right? That's just the y-axis. X is equal to 0. Now remember, that's not a function. Okay? Remember the definition of a function. We have an x value that's 5, corresponding y value. This is not all of them, but this is a couple of them. Just, 2 ordered pairs here of this set. Of course, this is an infinite set of ordered pairs, but notice that these two guys right here are the same. Therefore, this cannot be a function, right? Just a little refresher on functions there. Okay. Now let's break it down. We're going to break this all the way down. Let's say, for example, that we don't ever do that again. Never mind. Let's say, for example, we're given 0, 0, and we're given another point, and we'll say that it's 3, 3. We're given 2 points, and this time, so here's the origin, and then here's 3, 3, let's say. We want to find an equation that passes through both these points. Right, so we want to find the equation. We're given 2 points, and now we want to find the equation. First thing I'm going to do is find what's called m. And m is the slope. Alright, I'm going to find m, and then we're going to find, let's say, the y-intercept. Okay? And this is the formula we're going to use. Y is equal to mx plus b. So we're going to find m, and then we're going to find b. So hang in there. It's not going to be that bad. So this is how we do this. M is equal to y2 minus y1 over x of 2 minus x of 1, and you're probably wondering, what are these guys? We're going to label this point here x of 1 coordinate, y of 1 coordinate, x of 2 coordinate, and y of 2 coordinate. And then we're just going to use our formula to find m. Once we find m, then we're going to find b, and guess what? We're going to be done. Alright. So to find m, Scroll down here a little bit, see if we can squeeze all that in. So m is going to be equal to, now this is the slope of the line, m is equal to 3. So we're going to put 3 as our y2 minus our y1, which is 0, over, and the other one is going to be 3 minus 0. And so 3 minus 0 over 3 minus 0 is just 1. So our slope is 1. So slope is equal to 1. Now the idea is we want to find b. Okay? And so what we're going to use is we can either use this point or this point here. It doesn't matter which one we use. I'm going to use this one just because we have a 0 and a 0 involved, and it just makes things a whole lot easier. So y is equal to, our slope is 1, so I'm substituting this m right in here for 1. Now we have x plus b, and we're going to use the point 0, 0. So if you have a slope and a point, then we can find the equation to this line. So y is 0, x is 0, and we want to solve for b in this problem. Well, that's pretty easy, because 1 times 0 is 0, therefore b is equal to 0. So b is equal to 0. So the equation for this line is going to be y is equal to, now I'm not going to write 1 here, I'm just going to write x. And b is 0. So that's it. There's the equation, y is equal to x to this line. It's that simple. Of course, we're going to work lots of these examples. Okay? So let's work another one so you can get the hang of this. So you can get the hang. Let's say, for example, we had the point 1, 2, and the point 4, 5. We want to find the equation that passes through these 2 points. So the first thing we're going to find is m. So remember what m is. It's 5 minus 2 over 4 minus 1. It's the difference in y's and the difference of x's. Now, I want to say something else about this. We've been taking this number minus this number. You can do this number minus this number if you want, over, as long as you do this number first, 1 minus 4. Doesn't matter, because watch. 5 minus 2 is 3. 4 minus 1 is 3. And m is equal to 1. Okay? Now watch what happens here. 2 minus 5 is negative 3. And 1 minus 4 is negative 3. But a negative over a negative is positive, so we're left with 1. It has a slope of 1 also. So you see, it doesn't matter which one of these you use, just as long as you do it in the proper order. Okay? Well, we know what our slope is. M is 1. Now we want to find b. Now it doesn't matter which one of these ordered pairs we use. I'm going to use this one here. So y is equal to, m is 1, so I'm just going to write x plus b. Alright, and we're going to use the point 1, 2. And so 2 is y, 1 is x, and we want to solve for b in this problem, so therefore b is equal to 1. So now that we know what b is, we can go ahead and write out our equation. It was y is equal to, m was 1, so we don't need to write that, and it's x plus 1. Now here's something that I haven't done yet, and that is, let's check this. Okay, let's check it. So remember what our points, it was 1 and 2 and 4 and 5. So 1 and 2 is one of our points, and 4 and 5 is the other. So if I were to plug 1 into this, 1 plus 1 is 2. Okay, so that checks out. Now let's plug 4 in. 4 plus 1 is 5. So that checks out too. So this is the equation here that would represent a line that is passing through the point 1, 2, and 4, and 5. Okay? So given 2 points, we want to write an equation that passes through both these points. Alright, what if we had this? Let's say we have 1, 3, and 1, negative 5. We want to write an equation that passes through both of these points. So first thing let's do is find the slope. So we have negative 5 minus 3 over 1 minus 1. And so we end up with negative 8 over 0. Woo! That's undefined. Our slope is undefined. And so what this tells us is that something's fishy going on here. In other words, we're not going to be able to use this up here. Okay? Let's plot both these points. 1, 3. So let's say this is 1, 3. Or let's say 1, 3 is here. Okay? And this is going to be 1, negative 5, which is down here. Okay, so this is a vertical line passing through both these points. So this is going to end up being x is equal to 1. Alright, so that's not going to work. So let's keep that in mind. So this could be tricky, so be careful. That's okay. That's our equation, and this is the graph that corresponds with this equation. Now, let's label 1 right here on the x-axis. That's 1 right there. Okay? Alright. Okay, well, we've been given 2 points. We want to find the equation. Well, what if we were given the slope, and we'll say the slope is negative 3, and we were giving a point on the line. We're given a slope and we're given a point, and we want to write the equation. Alright, well, we just simply do this. Take negative 3, plug it in for m. This is our x, and this is our y. Alright, this is our y here. And then we just solve for b. So this seems like this is a whole lot easier than what we were doing earlier, but this is going to end up being positive 3. So b is equal to 4. So y is equal to negative 3 x plus 4. So as you can see, this number in front of x right here represents the slope. I don't know if I've mentioned that or not. And then of course we plug 1 in. We get negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. Right? Just checking things out. Okay. This number is our y-intercept, and this number is our slope. Okay. Y-intercept and then slope. So we want to keep that in mind, because if we're given this and we're asked to graph this thing, you know, we can just we know that it crosses on the y-axis at 4, and then, you know, we can find where the x-intercept is by setting this equal to 0 and solving for x. But let's move on now. I think you get this idea right here. If we're Alright, this time we're going to be given let's say that we're given 2x minus y is equal to 5, and we're asked to find m. And remember what m is. M is the slope. We want to find the slope, and we're just given this right here. So how are we going to do that? Well, one way to do this is we can always solve for y in this problem, and that is I'm going to take this 2x over to the other side, becomes negative 2x, multiply through by negative 1, so we have y is equal to negative 5, then plus 2x. Now remember, I said that this coefficient right here represents the slope, so m is equal to 2. So all you got to do is solve for y and then look for this coefficient that's in front of x right here. Alright, so let's take a look at another one of those. Let's say, for example, we had 4x plus 3y is equal to 6, and we want to know what is m, right? That's the slope. I'll write it out again so you don't forget. We want to find the slope of this equation, or we'd say the slope of the line if we graphed it out. So I'm going to solve for y in this problem. So that means I'm going to take this 4x over to the other side, and I'm going to multiply both sides by 1/3. And so we're going to be left with negative 4/3 x plus 2. That's multiplying this 1/3 across each one of these terms here. And so what is the slope? The slope is negative 4/3. The slope is negative 4/3. So it's that simple. Just solve for y in the problem and then look at the coefficient in front of x. Now there's something else that needs to be mentioned. When we were given 2 points or a slope, we were given m, say for example is 5, and a point, and we wanted to find y is equal to mx plus b. Now this form right here is the slope-intercept form. This is the slope and this is the intercept. This is known as the slope-intercept form. Okay. There's another form called the point-slope form. Remember, m is equal to y2 minus y1 over x2 minus x1. This is how we define the slope. But if I were to do this and take this x2 minus x of 1 over to this side, in other words, x of 2 minus x of 1 times m is equal to y of 2 minus y of 1 right here. Okay, and sometimes we do this. This is known as the point-slope form, and that is but usually we do something to this. Now I'm going to rewrite this back in this form here. We're going to write y though, this y2 right here, I'm going to just write a y minus the y1 is equal to x minus x of 1 times m. So I just kind of flipped it around and I went ahead and set this x of 2 and y of 2 just for y and x. Alright, so this is our point slope form right here. This is the point and then the slope. And of course, you can always take this y1 over to the other side, right, solving for y. Okay, so these are kind of the two forms. Sometimes you're just given this, you know, you want to find m or you want to find y. Okay, so some of these forms here that we've talked about, let's just review real quick on some of these forms. So if I were to write y is equal to, let's say, 3x plus 4, you should know how to find the slope of this, right? That's the slope. And then, of course, that's the y-intercept. You need to know how to graph this thing, okay? Remember, find the x-intercept points and the y-intercept points. Now, this is the point-slope form. This is the slope-intercept form. Slope-intercept. Slope-intercept form. This form, if we were to take this over, this is negative 3x plus y is equal to 4. What we're going to want to do is multiply through by a negative all the way across. So this becomes 3x minus y is equal to negative 4. This form is the standard form. Okay, this is the standard form. So they may ask you, given the slope-intercept form, write it in standard form. So you should be able to take the standard form and you should be able to find the x-intercept, the y-intercept, connect the points, so forth, and find the slope, of course, coming from here at the standard form. There was the, let's see, the y minus y1 is equal to m times x minus x of 1. This was the point slope. The point slope form. You're keeping up with all these forms there. Okay, so this is the point because you can plug a point in and then here's the slope. This is the point slope form. Let's see, there's one other form. There's the general form. And the general form is nothing but this right here, except we're going to take this negative 4 over. So we have 3x minus y, and then I'll bring that 4 over, plus 4 is equal to 0. Okay, that is the general form. Alright, so slope-intercept, standard form, point-slope form, and general form. Okay, so you just really need to plot a couple points, drive an equation that passes through the points and so forth. This linear equation is about as easy as it gets, actually, but let's see, here's a quiz question before we go, and this is definitely going to be tricky, so you better watch out. Graph y equals 0. What does that graph look like? Well, let me show you. So right here's the x-axis, here's the y-axis, and we just graphed it. We just graphed y is equal to 0. Right, y is equal to 0. Okay, the slope is 0, m is 0, the y-intercept is 0. Anyway, it's actually the x-axis. Okay, sometimes the easiest questions can actually be the hardest ones. I know that I've found that in many different cases. Alright, well, I think that this pretty much sums up graphing linear equations. Hopefully you won't have any trouble doing this, but like anything in math, it does take practice. So practice, 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 and I should have some practice exercise problems on my website. Hopefully one of these days in this particular section here. Okay, good luck.